All right, we're going to be talking about choosing a math programming solver. So really what to look for, questions you should be asking, and a bit about, when to make the change. So to give you a little bit more of an intro on myself and maybe why I'm qualified for this, and also so you can have two versions of me on the screen. As we mentioned, I'm at Garobi as an optimization engineer, but before I came here, I did my PhD at Carnegie Mellon, where I actually got to write software that was calling a number of different types of solvers. So I got to make some choices in that space. And then I moved into industry where I worked in oil and gas and a variety of real-time optimization, kind of planning optimization, as well as data science roles in oil and gas. And there I also got to kind of go through this process of what's the right solver for my application, what can I rule out quickly, and so forth. So throughout this talk, I'm going to be pulling from lessons learned at Garobi as well as my prior experience. So before I get started, what do I mean by optimization? So the first thing I learned when I entered industry is that optimization has a lot of definitions. And in reality, it can mean a lot of things. For the purposes of this talk, we're really looking at finding the best solution given a limited number of resources to meet the desired criteria by using math, analytics, and computer modeling. There's a lot of terms that kind of are associated with this. There's mathematical programming, which you saw on our title slide. There's a lot newer terms kind of in the decision space, so decision science, optimization, or analytics. A lot of this kind of falls under the operations research umbrella. If you look in the machine learning space, you'll see terms more like prescriptive analytics. And if you have a favorite term for optimization, feel free to toss that in the chat. We'll keep track of that as well. All right. So for the purposes of this talk, we are making a decision, and that decision happens to be choosing a solver. So I pulled up these basic 7 steps to making a decision, and this is from University of Massachusetts, Dartmouth. And we're going to walk through these steps and kind of map this to your decision of choosing a solver. Since you're here, I am kind of assuming that you feel that you might need to choose a solver. So maybe you've already identified a relevant business problem that needs to be solved and kind of identified mathematical optimization as the way to do it. We're going to start at gathering information. We will revisit kind of identifying whether or not you need to make this decision of choosing a new solver. But we're going to start the talk and spend most of our time discussing gathering information and identifying alternatives. Later, we're going to touch on weighing the evidence, choosing among your alternatives, and then really making the change. So whether that's changing to something like Garobi or switching to a different solver, depends on your business application. And then we're going to review that decision. So first up, we're going to look at gathering information. So what to look for in a solver and which solvers actually fit your business problem. And before we get too far, let's define what an optimization solver is. An optimization solver is a software that, as an input, accepts a mathematical model of an optimization problem. I think of it in 3 different parts. You have an objective. This is really the target, the thing you're trying to achieve. That could be minimizing costs, maximizing efficiency, things along those lines. You have kind of the barriers to, reaching infinite goodness in your target. So that might be limited number of resources. Maybe only have a certain number of workers that can fill shifts, things like that. And then you have some sort of decision variable or decision handle. These are the things that you can actually adjust to reach your target objective. And so for an optimization solver, it's going to take in that optimization problem and compute an optimal solution. And this has 2 main challenges. One is basic feasibility. That's really the ability to compute valid solutions to a defined problem. And then furthermore, you want to actually compute optimality. And so this could be the ability, or this is the ability to compute optimal solutions that can't be improved any further with respect to your objective function. And as we'll talk in a bit, your underlying model problem or model type is really going to help you take the first step in reducing the number of solvers down that you're looking at. And a question you might be asking yourself, or I would be in your shoes, Gurobi's a commercial solver. How can we as Gurobi be neutral on the topic? So we've structured this talk to really show you aspects of solvers, questions that you should maybe be asking yourself about the business problem that you have in front of you. We'll show you what we have kind of as a way of an example of what solvers can have, and then we'll allow you to compare. If you ever want to reach out to discuss further, we can certainly do that. All right, so I'm going to bucket solvers into these 4 categories. So there's commercial solver. That's where Gurobi falls in the mix. So there's possibly both a licensing and a maintenance fee. These often offer improved performance, maybe a more polished interface, and enhanced support. On the open source side, you're going to be pretty quick and easy to get started with a license because these are open source and free, but there's oftentimes a tremendous performance difference. And perhaps that performance difference on small problems isn't too big of a problem as long as there's no numerical issues, but kind of consider, you know, as your problem grows, troubleshooting and speeding it up can be more challenging. In the bottom left, we have modeling systems and frameworks, and there's a few of these where you can kind of hot swap solvers. So maybe you have your list of favorite commercial and open source solvers that you want to be able to switch between depending on your problem. There are some modeling systems and frameworks that allow you to do this. Some of them also kind of have back-end hooks into maybe data connections or help doing a front-end user interface. Next up, we have heuristics. These are really tailored smart strategies or algorithms that are kind of tailored to a particular business problem. They often need to be adjusted if the business conditions change in a significant way. You don't necessarily need a full mathematical formulation to solve it, or they don't need to necessarily exploit that structure. They can be potentially a little bit more black box. And you know what we find is they're good at finding feasible solutions. They're not necessarily going to be able to prove, or they aren't going to be able to prove optimality in the end. Those are the 4 basic buckets. Next up, we're going to walk through what to look for in your solver, kind of all the way from the core to outside the solver. Okay, so here's the 3 buckets that I would kind of envision is where you'd find interesting aspects of a solver. So we'll start in the core solver with capabilities and features. I'm going to go through those in a moment. And in all honesty, the features and capabilities are kind of in the software and ecosystem space as well as the core solver space. But to kind of keep this narrative a little bit more cohesive, I'll talk about them all at once. When I'm done with that, I'll go through performance. And this is really kind of top dog in terms of solvers, which is the performance. And so we'll go a bit into that as well. So the first thing you're going to want to think about is picking a solver that fits your model type. And this is really going to rule out a lot of solvers for you. And it's pretty simple to find out on a given solver if they're going to solve the type of problem that you have. So if you know you have a continuous or discrete problem, if you have constrained versus unconstrained, or maybe different types of curvature, linear to quadratic to nonlinear, and so forth. This is the common way to kind of distinguish model types and a pretty easy way to narrow down your solver. For this presentation, we're going to focus on mixed integer optimization. And we're going to do that because a large majority of business problems can actually be expressed through these model types. So I've splashed up a lot of different types of models that can be solved with mixed integer optimization. I'll highlight a couple. If we look in the top left with telecommunications, So they're really trying to transform their business to cope with changes and challenges created by the emergence of 5G. Some of those challenges might be in facility location planning or customer management and so forth. In the healthcare business, we've seen this kind of pop up as people adapted to the pandemic and trying to get hospital beds and staff scheduling at hospitals. But they're really responsible for safeguarding the health of their communities. And they want to do this in a high quality way and also in an efficient way. If we take a peek at oil and gas, so that's kind of the space that I come out of, mathematical optimization has been in place in oil and gas for well more than a half century. And it can be found in a number of different problem types. The ones that I was most closely associated with planning and scheduling, blending as well as real-time optimization. And in general, these mixed integer optimization problems, we see them as very prevalent because you can actually encode a lot of business decisions in them because they have the mixed integer aspect. So you might be able to have complex cost functions that might have tiered pricing. You can include yes, no decisions and all of their respective implications, conditional statements, and other arbitrary logical conditions. So there's really a lot of business logic that you can encode into mixed integer optimization, which is why we're going to be focusing on it. Next up, we're walking through what are the core capabilities and features that you should consider. I have 5 buckets, and there's a vast difference between solvers when it comes to these features. So to start off, we talked about supported model types. So the first question to ask yourself about a solver is, can it actually solve the type of problem I have? For a data point, Gurobi solves quite a few different types of problems, both linear and quadratic and bilinear, convex and non-convex, and then continuous and discrete or integer variables. And we actually have we solve the broadest range of problems, and this is regardless of size. And actually with 9.0, when that came out a couple of years ago, we started solving these non-convex MIQCPs, which is really cool in the blending space and to be able to do your pooling problems. All right, next up, how are you actually call the solver? So there's a lot of different interfaces depending on the solver that you might have in front of you. And the question to ask yourself is that solver available in an application or a language that my team is already proficient in? This is going to mean a lot toward, how fast you get a project up and running, how easy is it to maintain when it's being passed around the team for maintenance and improvements. So really consider that, what is your team currently using, and will the new solver be able to accommodate that, or is it going to be a little bit more of a learning curve? From the Gurobi aspect, we kind of pride ourselves in having a number of lightweight APIs. So we have everything from the Python interface, which we see a lot of new graduates and even folks in industry getting skilled up in. If you have a little bit more of a statistics background, maybe you're more proficient in R, or I know a lot of my engineering colleagues kind of learned programming in MATLAB, so that's definitely available as well. And we also have a number of compiled languages, including C, Java, C++, and .NET. So again, this is more reflective of what your team might need to be able to be proficient and efficient in picking up a new solver. Okay, so there are a lot of productivity tools in some of the solvers, and the real goal there, and I've kind of bucketed several things into productivity tools, but the question is, are there tools available that help you skip tedious, challenging, or error-prone modeling steps? So I encourage you to check out the solvers that you're interested in. The ones at Gurobi that really stand out to me are going to be, first off, our multi-objective models. We find that a lot of real life decision problems have kind of conflicting objectives or multiple objectives. That's one of the things that makes it a hard decision. Maybe you're trying to minimize environmental impact while trying to maximize profit or things along those lines. And these type of objectives can either be a weighted sum or solved as in a hierarchical way. And by Gurobi providing this, you don't have to do the coding yourself, which makes it a lot easier to kind of implement, and it's a lot easier to sustain down the road as well. We also have the ability to do automatic modeling of logical conditions. So that might be a number of arbitrary logical conditions or implied constraints, doing and or operations, things along those lines. Again, things that make your code more readable, easier to implement, and a little bit less error prone. And then along the bottom, we have automatic ways to linearize or approximate nonlinear functions. So in some cases, Gurobi is able to actually linearize your expressions during pre-solve where possible. If you have a more interesting nonlinear form, so think of square root or fractional power, an exponential or a logarithm, Gurobi is actually able to take that and do the piecewise linear approximation on your behalf. So you don't have to chase down all of those binaries on your own. And really what you're defining is your acceptable error. So these are 4 productivity tools. There are a few others kind of mixed within Gurobi, but consider the problem you're solving and how the solver can actually help you be a bit more proficient. All right. So say you've built your model, you've solved it. Next up is how do you actually analyze that model? I think it was a bit of a misconception when I came out of grad school thinking that a solution is the solution, and now people go forth and implement those results. And I found that it was not necessarily true in industry. There's a lot of times questions around understanding that solution. How do I mitigate a risk that I might take by making a change? Or even how do I cope with an infeasibility? And the more a solver can help you with those model analysis tools, the better you're going to be able to provide your customers or the business users with kind of meaningful tools for decision support. And I'm going to give an example of 3 of them that I really like. So first off is our multi-scenario models. This one really helps you ask a number of thorough what-if analyses to help you kind of learn more about a particular decision situation, perhaps run a sensitivity analysis to understand what's important and actually influencing a change of decision. And the cool thing about this is Gurobi actually solves this in a single run rather than solving them all separately. So you typically wind up with a much faster solve time on that. Next up, we have solution pools, which I have a Google Maps example shown here where I'm, for some reason, trying to go from Velvet Taco North to Velvet Taco South, and it shows me the optimal path in blue. But perhaps I thought, I don't really want to take the blue route. My favorite route is that gray line, but Google actually provides that as well. And when an optimization tool or a decision support tool is able to provide not just the optimal solution, but maybe a couple of alternatives, that means that me, the person who is finally making the decision of whether or not to take that route, I have a little bit more information in front of me. Maybe I know that my shortcut is in fact 5 minutes slower, or maybe costs more, or something like that. Whereas in Gurobi, you're actually able to systematically collect and retrieve these alternative solutions. All right, and every modeler's worst nightmare is just being faced with infeasibility. Worst nightmare is a bit hyperbolic, but it's super frustrating when you've done a lot of work on a model, or maybe there's a new data set and suddenly it's infeasible. And you don't have a lot of visibility into why that might be happening. And so infeasibility analysis can really help shed some light on why a model has become infeasible. So instead of asking why, you finally get to say, oh, okay, I guess that's why. And we have two tools within Gurobi to do that. We have IIS, or our irreducible infeasibility subsystem, that helps you really reduce the number of constraints down to kind of a more manageable level where your problem's probably in these constraints. Or fees relax, which is still going to offer you a feasible solution, but adds slacks to constraints that might be problematic. And this can really help kind of diagnose why there's some infeasibility there and still return a solution that maybe gives some information. All right, so those are the three model analysis tools that I really enjoy within Gurobi. Consider as you're looking at your solvers, what might be available there. And next up is solver tuning help. And it's really, how does your solver actually help you navigate the parameters that are there? Solver parameters really control the operation of the optimization engine. They turn off parts of the solver and on others. Maybe they increase the focus in one area versus another. And there are dozens and dozens of these parameters. More so, a bad parameter set versus a good parameter set could easily be an order of magnitude difference in your solution time. So the question is, how do you actually navigate the lists of parameters without doing a full PhD on each of the solvers you might be interacting with? Well, from the Gurobi perspective, we kind of give you two steps. One you don't see and is done for you. So we understand how the current parameters are chosen. And at Gurobi, we're really keeping an updated list of relevant problem sets to our customers with real world problems. Then our developers actually select some of our automatic parameters really to be most effective on most of these models. And this works really well for most problems. However, if your problem structure or data doesn't match most problems, it might be worth exploring parameters outside of the default. But as I mentioned, there are dozens and dozens of them. So in Gurobi, we actually provide an automatic parameter tuning tool that kind of helps you navigate our many parameters to make your model solve a bit better. All right, so we've talked a bit about capabilities and features that span the core solver to the software and ecosystem. Next up, we're going to look at performance. And this is a bit bearing the lead. We talked a lot about capabilities and features, but really the number one buying factor in mathematical solvers is speed. And I'm going to hop up on a soapbox and talk to you a little bit about why I think speed is important, but it does vary by business problem. So a fast solver might just mean I can solve the problem in a reasonable amount of time, which that is certainly important, but a faster solver can buy you a bit more. It can buy you robustness, it can buy you some scalability as your problem increases. Maybe it allows you to expand the scope of your problem. So instead of solving just within North America, maybe your problem can look at North America plus Europe plus South America and so forth. Maybe you're expanding in time. So instead of looking at a planning horizon that is over the next couple months, maybe you're able to look for the year. Maybe it allows you to include some amount of uncertainty and so forth. And what we wind up seeing a lot in this case is actually at some point, the scope may have had to be pared back in order to be tractable. But if you do find yourself moving to a faster solver, maybe reassess whether or not you needed to have shrunk that scope or divided up your problem. And hitting home for me, I did a lot of real-time optimization at my last company. If you have a solver that solves fast enough, you can have that in real time. It can be pulling in live data, solving it, and spitting out those results to be implemented automatically. And that's the real-time optimization is kind of on the operations end of things. And, I hear a lot that, there's a question of, is it important to have a fast solver if you're having planning discussions? So if you're planning, for the next 5 years, and maybe you're making this decision over the course of a month and several meetings. Having a solver that's fast can still be really important to be a voice in the room during that discussion. So if you're having a case where, I've had this many times where I've done an analysis, I go to the meeting, and the first question is either challenging an assumption or asking for the results if, this price set changed. And wouldn't it be nice to not have to respond with, that's an interesting question. I will go run some analysis and give you results next week. Now, if you could actually answer that in the meeting, would be great. Like you're going to wind up asking more questions. You're going to wind up making more thoughtful decisions based on really solid analytics. And if you have, let's say 10 times faster solver, you get to ask an additional 10 questions during that meeting. And really, the more questions answered, the more robust your decision is going to be, the more people are going to trust the model, and so forth. So at that point, you're really limited by the creativity of the questions that you can actually ask. What if I had one more truck? What if my price set changed? What constraints are actually holding me back? All right, so that was stepping off my soapbox. So the performance is also very important, and that's really kind of in the core solver area. Outside of the core solver in the software ecosystem, there's a consideration of deployment options. Are you looking to deploy your optimization model to run on one laptop? Maybe you want it to be run in the cloud or on a compute cluster, and so forth. Additionally, an expert tool really requires good documentation and extensive material to help train new users. So if we look at Gurobi as an example, we do offer what you expect. You can run Gurobi on your computer, and then without any interface change, you can actually set up a client server application where it's actually being run on a cloud or possibly being run on a server. And that way you can solve your model in a way that's most convenient for you and your existing IT environment. Next up, and I actually considered not putting this in here because I always find documentation to be somewhat boring, but we do hear time and again from customers that have moved to Gurobi that having the clear documentation available actually helps them be a lot more effective in their job. So, maybe when you're looking at a solver, take a peek at their documentation to see if it's going to make you effective in writing a model with that solver. All right, next up, we're looking outside the solver. So what is the company actually focused in? What does the development team look like? Is it a large development team? Because developing and improving a solver is a really difficult and time-consuming task and requires a special set of skills. I'm a bit biased in this because I am part of our support team, but also being able to ask complex questions about your optimization problem to your support team is really important for a lot of these expert tools. So if we look at company focus, from the Gurobi perspective, optimization is all we do. We have a single product and we focus in 3 main areas. One is remaining the most powerful solver on the market, so having technical superiority. The next one, and this kind of ties back to the productivity tools and the model analysis tools that we discussed. If we have a way to make it substantially easier for our users to use our product, we do that. We want you to have an easy time using Gurobi. And we're also very customer centric. So we see this in a number of ways. So one, we're certainly pulling in customer models to help our solver be better. We're looking at personal feedback from our customers, and we're really investing in our support team to support our customers. And this is our full stack of Gurobi's development team. These are the folks that keep track of our idea stack and customer requests. And while the Gurobi team is quite creative, we have a long list of ideas. So we really do look to our customers to understand how to make improvements to make their lives a bit easier. It really helps us prioritize. And performance is going to remain our key focus. And in fact, we're pretty obsessed with it. You can see our speed ups from version 1 to version 9. We had a 59x speed improvement over the past 9 years. And we get that in part because we do very extensive benchmarking. Before anything new is added to Gurobi, it gets benchmarked and tested against our around 6,000 and growing test library of real world problems. And making sure that we're getting correct and efficient results and really having a careful implementation is what we're getting out of benchmarking against this large test set. We ensure to never rush a release. And yeah, so we measure our performance against these real world test models, and that's what you're seeing here. But some wind up still pretty intractable. So we have a number of unsolvable models. But they have also been reducing quite significantly over the years. And these are generally a thorn in our developers' shoes. So they really dig deep and try to make sure that unsolvable models kind of get past the finish line. So past our development team, we also have a pretty extensive Gurobi support team. And again, that's the team that I'm on. So we have 24 optimization experts around the globe. And this means that you get direct access to PhD level experts. We offer advice and insights and collaboration. We have apparently over 200 years of experience with commercial models. And that's important because it really helps us understand the challenges that you're facing, because we've probably faced them before. We understand the mistakes maybe that you've made because we've probably made the same mistakes before and can kind of quickly correct them with you. And along the way, we're really curious about your model and your business problem. So a lot of times we'll ask questions that you might not expect about the problem type that you've provided us with, but we're really trying to understand what you're trying to achieve and how we can best help with that. So there's a lot of fun insights in your model that we're able to find. And as I mentioned, we really do listen to the customer. So I think in 9.5, it looks like we had 17 new features based on customer comments. And this is because we're really listening. So we're hearing where you're having trouble or where your life might be a little bit easier if you had some help. So this is a way that you guys are helping to shape Gurobi. And maybe to give you a feel for what support does kind of beyond the basics. Here are 4 support questions, or kind of more canonical question types. So in the top left in blue, we have, I am new to optimization, and I have written a blending problem that scales poorly with increasing problem size. It's definitely something that we see, that as things scale, it gets tougher to solve. And can you help me improve the solve time of my model? So we are there with you, even if you were completely new to optimization. We'll help you understand ways to improve your model, whether it's scaling or new parameters or a different type of restructuring of the model to get to where you need to be. Next up, we have, I'm not sure how many threads I need for my model. Can you help me understand the impact of performance? And we do a lot of help with customers trying to understand their architecture, what hardware they might need or would be beneficial for them, and what kind of deployment strategy they might want to have going forward, depending on what the given business problem is. In purple, we have my objective gets worse when I add a piecewise linear constraint. Why is this happening? And who hasn't run into the situation where they have a new software and they're just adding in new features as they find that they exist, and then something strange happens. And maybe you didn't read all of the documentation on exactly what went into all those features. Feel free to reach out to Gurobi support. Try this feature, here's what I was trying to do, and it did this, why did that happen? We'll help you understand why Gurobi did what it did, and if that feature is right for what you're trying to achieve. And then in yellow, we have most of my models solve quickly, except for this one. Why is that? And what can I do to make an improvement? This is actually somewhat common. A lot of our customers are solving roughly the same model structure with different data. And so maybe it's pretty consistent with most of the data, but one data set is really slow or causing it problems. And we can certainly help step in to try to understand what is going on there and how to improve it. Again, in terms of, are there things that we need to rescale, reformulate, or possibly suggest a parameter in Gurobi that might be able to help? And that ends kind of the discussion of the 3 areas of a solver to consider. So we looked through the core solver in terms of performance, as well as capabilities and features, which bled into our software and ecosystem, where you might also want to consider how you're going to deploy it, how you're going to understand that solver, and then beyond the solver, really consider, what is that company focused in? What does their dev team look like? And who are you going to ask for more difficult questions? So coming back to our decision-making process, we've gone through gathering information and identifying alternatives. What's next? So really need to kind of weigh the evidence and choose among your alternatives. And in the solver world, that really means you need to evaluate the solvers that are kind of in the top tier for you. And that's just through testing. So that's a bit of homework on your side to check out those solvers, test it with the models that you expect to be solving. From Gurobi's side, we can certainly help you benchmark against Gurobi. So if you send us your MPS files or your model files, we can certainly help check that out. And then next is to actually make that switch. So switch solvers as needed, or possibly rewrite or write your model to begin with. And switching to Gurobi is generally pretty easy and seamless in most cases. However, along with any interface change, APIs might be a bit different, but they're usually semantically pretty similar. You're going to be adding variables, you'll add a constraint, you'll make an expression and define your objectives and so forth. Gurobi tries very hard to make sure that we're compatible with all of the model formats, so MPS and LP and the REW format. But if you do run into challenges with an interface change, you can always lean on support to help. And I would also recommend that if you're in the process of making a solver change, this would also be a good time to check if your architecture could be refreshed. So consider whether or not a client server separation or a service encapsulation might be the way to go. And then after you've taken action, and maybe not right away, but at some point, you need to review that decision. Solvers are constantly changing. The ones that might work best on your problem today might not be the ones that work best on your problem, a couple years from now. So it's best to keep that understanding of solver performance evergreen. And if you're interested in going back to the start and identifying the decision, this is a really good time after you've kind of lined out and taken action on a new solver. And that's where we're getting back to that beginning. I promised we'd talk about identifying the decision. And try as I might to replicate rewind sounds, I cannot. So I've written it on there, imagine it as you will. And ask yourself the question, do I need to switch solvers? And really, it's going to be all about performance experience for the capabilities and features that you might need. But one thing or a couple things that might really flag a reevaluation is model runtimes don't scale with more data. Models tend to become larger, sometimes due to business demand or just kind of slightly changing business environments, maybe longer planning horizon, more products, more personnel, larger networks. And if your model is not scaling with your solver, maybe test it out in another place. The result of the current solver maybe isn't robust or reliable. The lack of an acceptable solution quality is unfortunate, even worse so if you have crashes or wind up with the wrong results. And lastly, the current solver maybe struggles with increased model complexity. So that could come in terms of maybe more granularity in the model. Maybe you need to add in some nonlinear terms that you didn't before, and it no longer works with the solver that you have in front of you. And so consider if you're adding, additional rules, multiple objectives, maybe that's another time to reevaluate the solver that you're using. But there can be a lot of benefits and improved performance. So I talked a bit about the benefits of a faster solver, and this can really lead to continuous and significant cost savings. It might lead to more questions asked in your planning meetings, so people can, or your planners can consider alternative scenarios. And really what we found is that most performance improvements are on the algorithmic level. So getting a bigger, faster, stronger computer is going to lead to potential improvements, but you're going to get more improvements through newer versions or possibly a switch of a solver. Making a switch like this always comes with certain risks. One might be the lack of knowledge. Changing a model generator source code does require some expertise. And sometimes the thing that makes the model now was built by somebody that has left the group long since. And so it might be viewed right now as a black box, where developers are maybe afraid to poke around too deeply in there in case they break something. So that's definitely something to consider. You might worry about a change in system behavior. So existing users may need to kind of get used to slightly different results, or different configuration options. And then there's certainly a deployment effort. So rolling out a software is not without its effort, as well as the additional testing period that's required. But generally speaking, if you're seeing a sufficient performance increase, these kind of risks are outweighed by the economic value that you're going to get by changing solvers. All right. If I can leave you with three main thoughts. One is that speed matters. It helps you offer understanding to your users, more questions asked, potentially larger scopes or real-time configuration. And the R&D and company focus matters. Is there a team behind this? Do I expect that if I make this choice today, I'm going to be making a different choice next year? And that can make things a little bit tougher. And support matters. If you have tough questions, are you, scratching your head alone in your office, or do you get to reach out to, a team of PhDs who are going to be able to help you understand what's going on and also how to fix it? And so with that, I would like to thank you. Open to answering any questions. And of course, feel free to email me at cozet@gurobi.com if you'd like a longer discussion.